Welcome to Our Ventura TV. My name is Nicole van Dam, and we are so fortunate to have with us today software engineering expert Jay Topping, who's going to talk to us about software engineering. Welcome, Jay. Thank you for coming.
Thank you, Nicole. I'm happy to be here.
How long have you been a software engineer?
I've been involved in software for over 20 years.
And to give our viewers an example of a sophisticated software engineering project that is something like robotics, would you explain your 5-axis machining solution?
Well, I was fortunate enough to have the opportunity to work on with a local manufacturer in developing a 5-axis control. And if you were to make a part using the traditional method, 3 axes, you would have a cutter above the part, and you would move an X direction, in the Y direction, and in the Z direction. For 5-axis control, you would move 2 additional axes. You would move a rotary axis this way, and you might move a rotary axis that way. This helps the manufacturer to make parts in a more efficient manner. He can use fewer setups to design his parts. Some parts, for instance here, I might move the part like this in order to manufacture a part. Now, for the software engineer to complete this, he has to be proficient in mathematics. He has to be able to come up with a solution on his own. He has to be able to use matrix algebra or something called quaternions to accomplish his task.
So you have to know math and things like that, but basically what you're doing is you're writing a software program that tells the machine how to operate the cutting tool and the piece at the same time.
That's correct.
So just to kind of step back to the most basic, what is a software program?
A software program is a set of instructions to accomplish and finish a problem. A software engineer will write these instructions and then deliver it or deploy it to the hardware so that the hardware can repeatedly execute these algorithms.
So when you say hardware, it's a device. So what kind of devices could it be?
Oh, it could be a phone, for instance. It can be a refrigerator or a vacuum cleaner, an airplane. There's software in your car today. Any device that you buy, most of the devices that you buy on the market now have software in them.
So it sounds like a software engineer is needed in a lot of different industries?
There's a great need for software engineers today. You have software engineers in agriculture. In Washington State, they're using robots to pick crops. You have software being used in entertainment for animation, Disney and Pixar. There's a multi-billion-dollar gaming industry that uses software, and the software engineer usually has to become proficient in programming and becoming familiar with the hardware that's used there. You have software being used in the medical industry for diagnostics. A doctor will give symptoms to a computer, and the computer can give them potential diseases that the patient might have. You have software being used in the financial industry for determining, for predicting what stocks may do. So software is used in many different industries.
So it sounds like whether you're putting software to use in a plane, in a drone, in a cell phone, in a refrigerator, any one of your examples, you need to write a software program. Are all the programming languages for all those devices the same?
No, they're depending on the field that you enter, you may have to learn a different programming language. There's a website called TIOBE, www.tiobe.com, that lists over 100 programming languages. And the current programming languages that are most used are Java and C. And just this month, Python, which has been around since 1989, entered the 3rd place as the most used programming language. Then comes C++, and then you have other languages. For instance, if you're doing web server programming, you might use PHP, JavaScript. You can go to that website and look at all the different languages being used.
So we've covered what a software program is. We've done something on programming languages. I've heard the phrase platform used. What's that?
Platform comes in two different parts. You have the hardware platform, which is your phone, your vacuum cleaner, your automobile, your airplane. That's the hardware platform. Then you have the software platform. Typical software platforms are Linux or Windows, iOS, Android. The software engineer targets the combination of the software platform and the hardware platform to develop his application.
And when we talk about hardware, how has hardware evolved recently to make more things possible?
Well, hardware has become cheaper and more diverse. You have more memory now than you've ever had in the past. You have, instead of using a single processor to accomplish your task, you have multiple processors, 4 or 8. Typical automobile may have 50 processors involved in it. And I've read recently that those 50 processors that control the brakes or the transmission or give errors to the user so you can take it in for service, that may involve 10 million to 100 million lines of code that software engineers need to work on and develop.
And has sensors changed at all, or?
Sensors have become more diverse. For instance, the self-driving cars use radar and something called LiDAR, which develops a three-dimensional model that the car uses to determine what is around it while it's driving. They have cameras to identify lines on the road, and there's accelerometers to determine the attitude of your device as you're holding it. There's many different options that are on devices that you use every day.
You know, you mentioned self-driving cars. Does that have to do with machine learning? How does machine learning work? For our viewers, what is machine learning and neural nets?
Machine learning has been in development for a long time, and just recently they've made great strides in it. It came out of AI and
AI is artificial intelligence.
Artificial intelligence and data scientists. Data scientists go through lots of data in order to identify categories for solutions. The data scientists may use hundreds of thousands of examples in order to train a neural net. To give you an example, if you wanted to identify if there was a face in a photograph, you would have to take, say, 80,000 photographs and show it to the camera that's running the neural net. So for instance, you would show a photograph with a face in it and say that has a face in it. You would show a photograph without a face in it and say that doesn't have a face in it. And after 80,000 examples, the neural net will know what a photograph with a face in it looks like. Then you have to evaluate that algorithm. You evaluate that algorithm by showing them, say, 20,000 randomly picked photographs that may or may not have faces in it, and you ask it, does this photograph have a face in it? Now, with today's neural nets, we can identify if a photograph has a face in it with a 99% accuracy rate. And this can be generalized to many different industries and many different problems and applications.
Now, self-driving cars, is that the technology that they're using, or is it something?
They're using neural nets in what they call machine learning in self-driving cars, and they drive the car around town and see how it does, and they correct it when it doesn't do something right. And the neural net learns how to identify pedestrians in a sidewalk, or how to determine if there's a stop sign coming up, any hazards that might be on the side of the road. And this knowledge goes to a central server. Now, the advantage of this is all this information that is put into the neural net, all the weights that control the neural net, can be downloaded to a car when it comes off the production line. So each car doesn't have to train itself. Each car is immediately, within a few minutes, given code such that it knows how to drive on the road.
So it's not like training every 16-year-old to drive.
That's correct. Each of us have to learn ourselves how to drive, but each car has the server where it gets its information.
So whether I'm using a self-driving car, or I'm using my word processor, or I'm using my cell phone, I'm dealing with what they call a user interface. I, the naive user who doesn't know software programming. What makes a good user interface?
User interfaces are important in the development of software to help the user and the customer use their application in an efficient manner. If you have 50 screens in a user interface, each screen has to be intuitive and consistent. So if you have an arrow that takes you away from the screen, it should always be in the same place. Software engineers have to develop the user interface so that it doesn't present problems, it doesn't have errors that come up. It's very important to develop user interfaces so that users can be productive.
So with all these advancements in, evolving software languages, evolving platforms, evolving hardware, for our viewers, are there some interesting things that you're impressed with in software engineering that they might wish to Google?
Well, control systems are interesting in that typically when they implement a control, they can't really test it until the moment that it happens. For instance, the Mars Curiosity landing on Mars, they couldn't test that. They had to do that in simulated software. So this requires software engineers to do all this. And it was very successful and impressive when that happened. The recent rocket landings on ocean platforms that SpaceX is doing, you can Google that and see how that is done and its accomplishments. The self-driving cars, although it needs more work, that's impressive. The medical industry uses software to help doctors diagnose diseases given symptoms. A doctor doesn't have time to read all of the publications that the medical researchers come out with, but a computer program can scan the internet and obtain this information and have it ready for when a doctor needs it.
So as a software engineer, when you're looking at a successful software project, assuming you had access to all the software programming and stuff, what would you look for to make a successful software engineering project?
What I look for when I look at a project that someone has finished is I look to see that it performs as it was designed to perform and as the customer wants to have it perform. I look to make sure that edge conditions are satisfied, that there are no problems with the software. I look for documentation. If a new engineer comes in to look at the software, can he quickly pick it up and understand it? Documentation is very important in software. I look to see that the testing was done properly, were proper edge conditions handled. These are the things I look for.
And advice for someone maybe thinking they might want to become a software engineer. What characteristics would the ideal software engineer have?
Well, he has to be self-motivated. He has to be a self-starter and start projects that he's interested in on his own. I would look for that. He has to have a 4-year degree, bachelor's, and maybe more nowadays. He has to have probably a good facility with mathematics. He has to be able to take a problem and work it out himself, derive equations on his own. He has to have attention to detail. Software engineers can't just throw a few strokes on a canvas and be done with it. You have to pay attention to every little detail and be
so meticulous and yet creative at the same time.
That's correct.
That's
yes.
very unusual. We're almost out of time, and this is such a broad subject. I'm sorry. Thank you so much for coming. Is there a website that people can go to learn more?
You can visit www.system-art.com, and you can leave a question there and I will answer it if I can.
Oh, thank you so much. This is Nicole van Dam signing off for this segment of Our Ventura TV. I hope you found this program worthy of storing in your database.